So let's derive torque on an electric dipole in a uniform electric field. Suppose these lines represent a uniform electric field in a given region, and say they are represented by E bar, and since they are representing uniform electric field, thus they are equally spaced. Now since these lines are from left to right, therefore this must be positive terminal on the left side and this must be negative terminal on the right side, as electric field lines moves from positive to negative terminal, meaning they start from positive and end at negative terminal. And now suppose there is a dipole, electric dipole inside this uniform field somewhat like this. So we need to find out what is the torque acting on this dipole. So let's represent, say, plus Q here and say minus Q here, and let's name them. Say this is charge A, this is charge B. So since unlike charges attract each other, therefore this charge would be attracted towards right side and this charge would be attracted towards left side, and the force that acts on this charge would be Q into E by definition of force and electric field and charge. In same way, force acting over here would be Q into E again, and the distance between the two charges, as we already know, is represented by 2L, meaning the length of the dipole. Now let's try to find out what torque is acting on this dipole. Let us extend this line and drop a perpendicular from A to this extended line. Now this angle would be 90 degree, and suppose this is some angle as theta, and let's name this point as D. So now in this triangle ABD, side AB would be 2L sine theta, using the trigonometric property of sine. Like sine theta would be opposite by adjacent, therefore this side AD would be 2L sine theta. Now let's do the formula part. We all know that magnitude of torque is given by R cross F mod. So here R is 2L sine theta, the perpendicular distance of the force and the point of rotation. For this force, this QE force, point of rotation would be this B, and the perpendicular distance of A from B is like AD, which is 2L sine theta. So we have R as 2L sine theta, and force, as we know, is simply Q into E. So therefore magnitude of torque over here is given by Q into E into 2L sine theta. So on rearranging these terms, we get something like Q into 2L sine theta. Now we know what Q into 2L is from previous derivations. Q into 2L is nothing but dipole moment. So our formula reduces to EP sine theta. So this is the magnitude of torque acting on this dipole in a uniform electric field. Suppose if we need to write it in vector form, so it can be written as P cross E. And for vector form, we must remove this mod. So torque is equal to P cross E is the vector form for this, as we know A cross P would be A mod A mod B sine theta into n cap. Here n cap actually represents the direction, same way here n cap would represent the direction, but n cap small would be 1, therefore it doesn't matter if you write it in